Hi, my name is Chelsea Schlotman, and today I will be going over Module 4 written exam with you, and it is going to be about fractions and rational numbers. So first, we're going to look at number 1, and it says here we are given 4 different shapes. We have a hexagon, we have a trapezoid, we have a triangle, and a rhombus. We're going to look at each of those shapes individually and see what part of that shape will fit into others. We're going to have 4 different sets because we have 4 shapes, and within each of those sets, we're going to have 3 fractions. So first, we're going to start off by looking at the hexagon. And I have a hexagon here listed for you so that way you can have more of a visual. And as you can see, it takes 2 trapezoids to make 1 hexagon. Next, we're going to look at the triangle. And I have triangles here posted as well to fill in that hexagon for more of a visual. So we have 1, 2, 3, 4, 5, and 6 triangles will make 1 full hexagon. And then we're going to look at the rhombus. And if we see here, it says 1, 2, and 3 rhombuses will make 1 full hexagon. Next, we're going to look at the shape trapezoid. And we're going to start out with a hexagon, and as you can see, that 1/2 of the hexagon is equivalent to the size of 1 trapezoid. And for the triangles, we see here that it takes 3 triangles to make 1 full trapezoid. And last, we're going to look at a rhombus. And this one seems a little more complicating, but it really isn't. You can see here I have a rhombus inside of a trapezoid within it. And then on top of it, I'm putting 2 triangles to show you that that leftover portion is a triangle, so that would be another portion. So the rhombus is 3/2 to make 1 trapezoid, or we can make it a mixed number, which would be 1.5. So 1 full rhombus and then half of another one. And I gave another little example here to show that half of a rhombus is 1 triangle. And next, we are going to look at the triangle. Alrighty, and we're going to start off with the hexagon like we did previously. And for that, it shows here 1 hexagon is equivalent to 6 triangles. And it's kind of like when we were looking at how many triangles would fit into a hexagon, except our fraction is flipped. So it would be 1/6 this way. And next, we're going to look at a trapezoid. For 1 trapezoid, you would have 3 triangles. And for 1 rhombus, it would be 2 triangles, or 1 triangle per rhombus. And then for the rhombus, we're going to start out again with a hexagon. And as you can see, 1 full hexagon would take 3 rhombuses. And then for the trapezoid, you can see 2/3 of the trapezoid would be a rhombus. And then lastly, we're going to look at the actual triangle here. And within that rhombus, you can tell that it is half of the rhombus. So it would take 2 triangles to make 1 full rhombus. And next, what we're going to look at, we're given a piece of rope. And we're given 2 different markers on that rope to label a different amount of rope that was used for something. And then it gives us the 36 feet that was left over. So here, this first section that is marked off, it's 1/3, which was used for a bow painter. And then the second section is 1/4, and it was used to tie a roll of carpet. This last section here is going to be 36 feet. Now, what we're needing to do is find out what the original length of this rope was. So how we would do that is we would section off this remaining portion, the 36 feet, into 1/4 sections. And then with those 4 sections, we're going to divide 36 by 4 because we have 4 equivalent 1/4 sections. And that would give us the answer of 9. So each section is going to be 9 feet. And then after you do that, you would go ahead and section this 1/3 in half because that would be 2 1/4 sections, and also label that with 9 as well. So to find the final answer of how long the original rope was, you're going to take each of those sections, and if you count here with me, we have 1, 2, 3, 4, 5, 6 sections, and each of those sections is equivalent to 9 feet. So we're going to multiply 9 times 6 to get our answer, which is 72. So the original length of the rope purchased was 72 feet. Next, we're going to look at some fraction strips. So we're given a fraction. We have a fraction problem, which is going to be 1/3 plus 1/2. So we're just going to make a fraction strip that will represent each of those fractions. So for the first fraction, 1/3, we have a strip into 3 sections, and one of those sections is filled in to represent 1 out of 3. Then we'll do the same for the second one, 1/2. Excuse me. And then what we're going to do in order to find our final answer for this, we're going to have to change our denominators because we cannot add 2 unlike denominators. We're going to have to change those. And in order to make 1/3 have a denominator of 6, we would have to multiply it by 2. So the whole entire fraction would be multiplied by 2. So our new fraction would be 2/6. And we'll do the same thing with 1/2. We'll multiply it by 3 and get our new fraction of 3/6, or 3/6. So now we're going to make a new fraction strip represented for these fractions, these new fractions that we have. So you can see we have 2/6 and 3/6. So we have 2 out of 6 that are colored in to represent 2/6, and then we have 3 out of 6 to represent 3/6. And in order to add those, we're basically going to bring down the 2 here. And as you can see, there's 2 at the beginning. And then we're going to bring down these 3 here. And we'll also have a new strip, and it would be 6 sections because our new denominator is 6. So that the denominator always tells you how many sections in that strip that you're going to have. So you will notice we have 6 different sections within one strip. So then we just pull down the colored portions, and that would give us our new answer. If we add those, we have 1, 2, 3, 4, 5 out of 6 are colored in. And then here I just basically gave it to you straight across. You leave the denominator the same, and you add the numerators, which would be 5/6. And another way we're going to look at that is with a number line. So you just create a normal traditional number line. You label it with your fraction, and I went ahead and I just added the 2/3 and the 3/3 to show we're working with the whole. You don't have to do that. So with our first fraction being 1/3, we're going to start here at 0 and count spaces until we get to 1/3. That would be 2 spaces. And then the second number line is going to represent 1/2. We're going to do the same exact thing. Start at 0 and count how many spaces it takes us to get to 1/2. And it takes us 3. And you will recognize here that we have the same numbers that we have here on the top for our numerators, 2 and 3. We just add those, and then you count how many ticks you have in total. That would be your denominator. So it would be 5/6. Part B is the exact same, just different numbers. So we have 1/2 plus 3/4. And then on this one, it is a little bit different. We don't have to change both denominators because one of our denominators on the first fraction can actually be multiplied by 2 to get us to the same denominator that we have on the second fraction. So here you can see I've multiplied 1/2 times 2, which gives us 2/4. And so our new fraction strip will represent 2 out of 4, and then we'll keep the other one the same, 3 out of 4. And we do the same thing. We bring down 2, and then we bring down these 3, and that gives us our total here, which is going to be 5. So you can see we have 4 in one section and 4 here. So we have 5/4. Or if you wanted to make that a mixed fraction, it would be 1 and 1/4, because we have 1 full section here plus 1 out of 4. So 1 and 1/4. And we'll do the number line the exact same way. Start at 0, and we're wanting to get to our 2/4. So we go 1, 2, 2 here. And then on the last one, we're going to try to get to our original 3/4. So start out at 0, move over until you get to the 3/4. So 1, 2, and 3. So we would add the 3 and the 2 and get our 5/4. And part C and D are just subtracting instead of adding. They are done a little bit differently. So as you can see here, I created the same type of fraction strip, 3 out of 4 and 1 out of 3. And then I did the same thing as I did previously. We make our denominators the same. So here we would multiply 3/4 times 3, and we would multiply 1/3 times 4. And we take those same exact fractions that we just got, 9/12, and make a new strip. We do the same for 4/12, and then we're going to subtract those. And the way we look at it, the strips to find our answer is the first 4 here, and the top, and for the top, the first 4 there, we're basically going to be canceling those out. And then, like I said originally, you're going to have 12 spaces because that's what our denominator here is. And then you just bring these last ones here all the way down. And you will notice that that gives us 5/12. The number line works similar. So what you're going to do for this one is you're going to start out at 0 and jump all the way over to the 9 out of 12 marks. And then for 4/12, you're going to start at the 4, the 4th marker, and move to the 9 as well. And you'll notice here in between, we have 1, 2, 3, 4, and 5 marks left. Excuse my little marks here. I can't keep them straight. So our new fraction on a number line would be 5/12 again. And then D is the same type of question. So as you can see, I changed my denominators. I made my new fraction strips, and I got my answer of 3 out of 12. The number line will be worked the same way. We start from 0 and jump all the way to the 9. And then the denominator, the second fraction is a little bit different. So we start out at the 6 this time, which is right here, and we jump to the 9. Again, we're going to count the spaces in between 1, 2, and 3. So our new answer will be 3 out of 12. So for number 4, what we're going to be looking at is some fraction circles this time, and we're also going to make a number line to represent those as well. So our first problem on number 4 is 3 times 1/5. So what we're going to do is we're going to make 3 fraction circles, and each of those circles will represent 1/5. So then you just see we add the shaded portions 1, 2, 3, and that gives us our answer of 3/5. And the number line, it's a little bit different than when we add and subtract fractions. With multiplication, you're going to look at your denominator, and that's how many times you're going to section your number line. So we have it in 5 sections, and then we're going to look at our whole number that is provided, 3. So within each of those 5 sections, we jump 3. 1, 2, 3. 1, 2, 3. And then if you count all of those up, it's going to give you your answer. So then we are going to look at part B. We have 3 times 2/4. We're going to do this one the exact same way. We are going to have 3 fraction circles, and each of those circles will represent 2/4. So here we go. We have our 3 circles, so 2/4, and we have, if we count those, we have 2, 3, 4, 5, 6. So our answer would be 4, 5, 6. And the number line will work just as the same way we did previously. I'm so sorry, let me go back there. Okay, so we're going to start out here in our 4 sections because we have 4 as our denominator, and we count each section. 1, 2, 3. So we will have our new fraction, which would be 6/4. And for C, it's going to be 5 and 5/8. 5 times 5/8, I'm sorry. So you can see here I have 5 fraction circles, and each of those have 5 out of 8 filled in. So if we look here, we would have, here's our answer, we have 1 full shaded circle of 8, and we have another one and another one. And this one down here only has 1 section filled in. So we have 8 times 3, which is 24, plus 1. So we'd have 25/8. We're going to do this one on the number line as well. So we're going to section it off, and our denominator here is 8. So we're going to have 8 little ticks in between each section. So what we're going to do here is we're going to jump 5, 1, 2,